Hello friends, this is Durga again from IT Varsity, one stop shop to learn all the technologies. So this is the session 5 of Scala and Spark workshop. So far we have seen basics of Scala, and then we have written a word count program, and we have understood how the programs are executed in Spark. So we have seen development lifecycle as well as execution lifecycle using Spark and Scala. Now we'll start. We'll take it further, and we'll try to understand how to write more complex program using several transformations as well as actions. Okay, so before we get started, I will recommend you guys to download a dataset onto your local file system. For that, you need to go to GitHub. Just give me a moment, okay? One minute, okay? I just want to make sure that it is not frozen. Yeah, it looks good. Okay, so I will highly recommend you to go to this github.com, and then there is a repository called data. So this is the URL which you can use. Okay, so I will highly recommend you to go to this location and then download the repository. Okay, and the way you can download is either you can click on this. Either you can download it as zip file, or you can copy this URL. And if you have Mac or something, Linux and all, Git will be automatically installed for you. You just have to use. You just have to go to respective directory. So first I will show on Cygwin or Mac or Terminal, and then I will show how to download it as a zip file on Windows-based systems. So if you have Git installed, you can validate by running Git. Hit enter. If it does not result and if it throws help, that means Git is installed. You can go to any directory. In this case, I want to download it to this location, and then you have to run git clone, and then paste that URL which is copied from there. Okay. Then it will take some time to download the entire repository because it's quite big. Okay, it will take some time, so you need to be a little bit patient. So whoever have Mac and Linux terminal, just run this command in the after you go to the appropriate location and download everything. And others who don't have Mac and who don't have Git installed, what you have to do is go to the same URL and then click on download zip. It will download the zip file. It's quite big, 146 megabytes. You can download that one. It will take some time. And once it is downloaded, you can unzip it to the location you want. And whether you use git clone to create a copy of it or download and unzip, you should see this directory called retail_db. And when you click on this retail_db, it should have 6 subdirectories: categories, customers, departments, order items, orders, products, etc. Okay, so make sure you download and make it available on your local file system, because we'll be using IntelliJ again to develop the program, and we will validate locally first, and then we will try to test it on the cluster. So I will give 2 to 3 minutes of time. Everyone try to initiate the download, even if it takes time. And then after 2 to 3 minutes, even if it is not completed, I will go ahead and start covering the data model. Within 10-15 minutes, everyone should have the data downloaded. And then after covering the data model of this database, we will actually get into writing the program. So here I am giving only 2 to 3 minutes for you to kickstart the download. Either you can use git clone like this, or you can download and unzip it. It's whatever you want to do, you can do. Okay, and also if it is already downloaded, make sure you have unzip it. You unzip it and you see directory called retail_db, and that retail_db should have 6 subdirectories. Okay, if anyone have issues to download, let me know. I will help you to have the dataset available for you. So after today, we will have next session on the coming Saturday, and it will also start at 9 a.m. So I'm scheduling the event by the time you kickstart the download. So whatever will be remaining, like Spark, SQL, and streaming, will be covered as part of the next Saturday. Okay. So I hope everyone have started the download. Hence, let me go to the data model. So to get the data model, you can search for this Cloudera exercise 1. Okay. And you can go to this URL. And here you will see the data model. Okay, so the data model has 6 tables. This is simulating a retail e-commerce platform. And out of these 6 tables, typically in any database, you can categorize tables into several categories. One is transactional tables, other one is master data tables, third one is workflow tables, and so on and so forth. Okay, for business use cases, typically you will have transaction tables and master data tables. So out of these 6 tables, what is transaction table? Whenever you try to transact with the business, the tables which will store the information related to those transactions are called transaction related tables. Okay, so if you think about any e-commerce platform like Flipkart, Amazon, etc., what is the transaction in them? Typically, you go there, you search for a product, and you add it to the cart, and you make the payment, and then your order will be in several stages. Eventually, it will be shipped and completed. Okay, so there should be some tables which will be storing information about your order items, etc. And these are called as transaction tables. So out of these 6 tables, as it simulates the e-commerce platform of a retail company. Order items and orders are the transaction tables. So what is an order? You go there, you place an order, and within order there can be n number of items. One order can have multiple items in it. What are the properties of our items? Typically, the product ID, which product information which you are trying to buy for each item. And if you are buying something like water bottles or some other item which you typically buy multiple things, there will be a quantity for that product, and then price for the product, and quantity multiplied by product price will be subtotal. That is for each order item. And at order level, there can be multiple entries. So for one order, there can be n number of items. So all the order items go to this table. All the order related data goes to this table. What are the attributes for orders? The date on which order is submitted, and the customer ID or the customer information who have submitted the order, and the status of the order. Those are the typical attributes of the orders. Order items is at the item level. And if you see the connector between the two, okay, here you see the fork, and here you see something like 10. Okay, so this is the data modeling representation of relationships. Here, whatever side you have the fork connector, that is many, and whatever side you have this symbol, it is one. So the relationship between orders and order items is one to many, because for a given order there can be a number of order items. And then so typically you might have heard about normalization form and all, normalization and all. Any relational database should be at least in 3NF, third normal form, or BCNF, Boy Scout normal form. Okay, it is, I think, in 3NF, and in the 3NF form you should reduce the redundancy of the data, and you have to have multiple tables where one-to-many relationships are applicable. And one of the one-to-many relationship is between customer and orders. One customer can place a number of orders for his lifetime, right? That's why you see one here and many here. So one-to-many relationship between customers. This actually contains the customer ID, the name, first name, last name, email, password, street, city, state, zip code. And orders have order customer ID. And by joining these two, we can get the information of the customer if it is required when we want to run some analytics. So, and the customers is kind of it's not a transactional table, it's kind of a master data table. Only new customers will try to fill a form and register as a customer. And then they can place several orders in their lifetime. Similarly, each orders are related to products. One product can be part of many order items. That's why you have one-to-many relationship between product and order items. And products can be categorized, and categories can be multiple categories can be part of the department. So these are the 6 tables which constitute this data model, and you should see this and try to understand what is the relationship between the two tables. Now let us understand the tables a little bit further, and then we will define the problem statement. Okay. So here, these tables on top of the files I also have in MySQL. And to connect to the MySQL, first you need to go to the lab. I'm connecting to the lab here. And for the password, you have to go to labs.itvarsity.com. Okay, and then from here you can run MySQL-u retail_dba. Everyone have access to this. -h nn01.ipvarsity.com -p for the password. It will prompt for the password, and the password is itvarsity. Okay, so now if you log in as retail_dba and then list the databases by running show databases command. I will paste the command in a moment. you can see this retail underscore DBA user. So this is user, and these are the databases. This guy, this user have access to these 4 databases. Forget about information schema. It is primarily a data dictionary schema, which will maintain the metadata about the tables and databases within the database. On top of it, I have 3 databases which starts with retail. One is retail underscore DB, second one is retail underscore export, and third one is retail underscore import. So retail underscore DBA have permissions to these 3 databases. Out of these 3, retail underscore DBA have only read-only permissions on this. So you can query the tables from the database, but you can never insert or update or delete or create new tables or drop existing tables from the database. Okay, so retail underscore DBA user have read-only access to retail underscore DB. Okay, and then there are these 2 are playgrounds for you. You can switch to those databases and you can do whatever you want. So in this case, I am connecting to retail underscore DB. Okay, now I'm connected to retail underscore DB. And if I run show tables here, it has 6 tables. Okay, and then if you run, so we'll start with the departments. Departments is the highest order table in the hierarchy. Department have multiple categories. Categories have multiple products in each category, and products can be one product can be bought by many order as part of many order items. So one to many from products to order items. So hierarchy is this one. So here we will start with the departments. You have these 6 records. Forget about this one. Don't worry too much about it. So there are 6 departments: development, footwear, apparel. I think this one is something else. Someone might have updated it. Let me see. If you go back to the data which is copied, you can also validate the data by going to appropriate directory and cat in those. Actually, 2 is fitness. I don't know how development came into picture. Fitness, footwear, apparel, golf. They have permission update departments. Set equal to fitness. Most likely it will fail. Yeah, it's not there. Anyway. But anyway, denied to user, yeah. So there is an issue with this. That's fine. We can ignore for now. I will fix that later. And let me fix it. I'm connecting as root. You will not have permissions to connect as root. Okay, it's not that. Just give me a moment, okay? I'm fixing it. Okay, and then delete from departments where department ID equal to 100. Okay, commit. Now if I run this, okay, now it is fixed. And now if you go to the next table, select star from categories, limit 10. has three fields. One is the category ID, second one is category department ID, and this is the foreign key to the department ID in the departments table, and category name. So within fitness, we have football, soccer, baseball and softball, basketball, lacrosse, tennis and racket, hockey, and more sports. So these are the categories within fitness department. And then if you say select star from products, limit 10, and this have 6 columns. Product ID, product category ID is foreign key to the categories table on category ID, and then the product name, product description, product price, and product image. Okay, and then if you go to the order items and run limit 10, it has 7 fields. Order item ID, order item order ID, order item order ID is the foreign key to orders table on order ID. Order item product ID, which is foreign key to products on product ID of products. Order item quantity, order item subtotal, and order items product price. And then select star from orders, limit 10. You have order ID, order date, order customer ID, order status. And then customers. So orders have foreign key relationship to customers using order customer ID to customer ID of customers. And these are the several fields of customers: ID, name, last name, email, password, street, city, state, zip code, which will constitute the address of the customer. Okay, so out of these 6 tables, let us define a problem statement and let us try to implement in Spark. Okay, so here we have the same data already cloned as part of by running the git clone command under retail_db with comma as the delimiter. So it has exactly the same fields of same data types, and data is comma separated. Okay, now let us define the problem statement. Again, I'm going to the data model. So in this case, let us say that I want to get all the completed as well as closed orders, and then get the revenue for those orders, okay, aggregated by date. So I just want to know what is the revenue generated for each date, and the criteria is only the completed and closed orders. So out of these two tables, out of these tables, how to get the so first let us define the problem statement. Okay, so here I am creating a new package, and the package name is retail. Once we create the package, we will create the Scala class of type object, and let me name it as daily revenue and click on OK. Okay, and let us define the problem statement here. Get the total revenue per day for all completed and closed orders. Okay, so this is how the requirements will be typically. So first we need to understand this and try to map with the application and get the technical specification out of it, and then we should start the implementation. So let us design, and as part of the design, what is the criteria to get the orders? There are 2 criteria. One is we want to get data by date, and the other one is we want to get only completed and closed orders. Okay, and if you think about it, here this is about filtering data from orders table to get complete and closed orders. And if you go to the data model and see which field can give, it is order status. Okay, so order status is the 4th field in the data, and using this order status, we should be able to get complete and closed orders. So let us first launch the Spark here. We can actually do it on our local file system also. I hope everyone have copied the data. And in my case, the location of my data is this one. Okay, so this is the path of the base directory, and in that we have products, orders, order items, etc. Okay, now I will try to use only Spark as much as possible to explore the data, to develop it, and process the data as per our requirement. First, I will develop using SBT console. Then I will create the application as part of the IntelliJ, and we'll develop and we'll run. We'll test it. So here, where is my project? It's under IDEA projects, S&S. This is where we are trying to develop all our applications. Okay, and I have created the retail directory in this, and this is the path of the project. You can also do copy path and paste it over here, and then launch a Scala with the Spark packages which are already defined in build.sbt. By giving SBT console, it will launch Scala with all Spark-based packages, the way we have done with the word count program. In this, first we have to create the configuration. So first I need to import org.apache.spark context spark conf. Okay, and then val, I can directly say sc equal to new spark context, new spark conf, set app master local dot set master local, and then set app name daily revenue. Okay, so instead of creating conf object and then passing it as parameter, I am creating the object while passing it as parameter directly to the construct of Spark context. Now the Spark context object is created. Okay. Now, first get the data of orders. So here, first we need to understand the file format. File format is text file. So we can safely use fc.text file to get the data. And what is the path? The path is users IT varsity research data retail underscore db orders. Okay, and it has created the RDD, and each element of RDD is of type string because we are using sc.text file. Let us review the data. Orders dot first will give the first record, count will give the count. You can see data is comma separated. This one is order ID. If you match with the data model, order ID, order date, order customer ID, and order status. And now if you want to get n number of records, you can actually say orders dot take 100 for each interval, and you can see the data. And here we are interested only in complete and closed orders. Complete and closed orders. Completed, for completed orders, the status is complete, and for closed orders, the status is closed. Okay, so we need to get only these orders, and then we have to and also to get the revenue, we need subtotal. Okay, and subtotal is part of order items. So once we filter out for complete and closed orders, we can join with order items and get the subtotal, and then group by order date, and get the total of the subtotal, which will give us the results of daily revenue for all closed and completed orders. Okay. So first, we need to filter the data. Filter orders for complete and closed. Okay. So to do the filtering, what we need to do? We need to apply we can create a variable called val orders filtered equal to orders dot filter. Okay. And then we can actually say rec dot uh, rec dot split comma equal to complete or rec dot split equal to close. I didn't close the bracket here. I have to do that. Okay, so this expression will return true if the sorry, I have to do rec dot split will actually create an array, and out of that array, I want to get the fourth element, which can be accessed by 3. And then we are comparing with complete or closed, and hit enter. Okay, or we have to use 5, double 5. Okay.
Not the underscore. Have to use the underscore.
No. Underscore is only for tuple. Yeah, you need to collection is different and tuple is different. Okay, for array for any collection we have to use this only. Okay. So here it has created a new RDD which will have the filtered data with complete and closed orders. You can say orders filtered dot count to see whether any data filtered. Yes, we see only 30,455, whereas orders dot count becomes 68,883. You can also say orders filtered dot take off 100 for each interval, and there will be only complete and closed orders. Okay, this is how you should validate. And as part of the filter, you can use any expression which will either return true or false. Okay, so you should know how to apply Boolean operators, how to compare with the substring, etc. So for example, in this case, let's say I want to get pending orders. Okay, now if I run take off 100 on orders again, there are 1 minute. So there are 2 statuses which have pending as part of it. So if I want to get all those things which have pending as string, what I can do, I can say orders dot filter underscore dot split. Okay, if you don't want to give the name, you can use underscore for simple expressions like this. And 3 dot contains pending. Okay, and you can actually say take off 100 for each interval. You see now all are pending and pending payment. So if you want to, instead of processing like this, if you want to create a object and assign the stuff into the object and use objects, what you have to do first, you have to create a case class. Let us recollect what a case class is. Case class is nothing but a, let me create a case class here. I am creating case class orders. So you can address the problem in multiple ways. Okay, one, you just process similar to the scripting language, the way I have filtered earlier for complete and closed orders. And second one, you can do it object-oriented way using classes, objects, etc. So if you want to use if you want to create a class and first create objects of that type and then do additional processing, you can create case class like this. Okay, order ID integer, order date string, order status, sorry, order customer ID int, and then order status string. Okay, now the case class is created, and if you, I think this one will not work. Java p hyphen p orders, it will not work. But let me launch Scala. And then copy. Okay, in this, if I run Java p hyphen p orders, you can see you get functionality for all these methods. Okay, and also we have a companion object Java p hyphen p orders dollar. This is the companion object which have the apply method. Okay, so we can use this apply method and we can actually create the objects. Okay, now if I want to create RDD of type orders rather than string, after uh, uh, on top of the orders RDD, I can say val orders. Let me use orders itself, sc.text file. I'm reading again. Users, IT Varsity, research, data, retail underscore DB, orders. Okay, dot. First, we need to apply map function so that we can pass it to filter later. So map, right? Here I want to write multiple lines, code in multiple lines. That's why I started curly braces and went to the next line. And then I have created a variable called r equal to vect dot split. And I'm splitting by comma, which is the delimiter. And now I can say orders are of 0. By default, when we actually split, let me show here. Let's take the example of this data. Okay, val s equal to, so this is the string. And if I say s dot split by comma, what is the output of it? It's nothing but array, and it will have array of type string, and it has, after delimiting, it is tokenizing into 4 strings, and it is creating array out of it, right? So here also it will be the same thing, and each element is of type string. But here order ID is int and order customer ID is also int. So we have to typecast by using toInt. And then R of 1 is already string, so we don't need to use. R of 2 also we have to use toInt. And then R of 3. Okay. And then if you hit enter, yeah. Now you should see the new RDD by name orders is created after applying the map function, and each element of this RDD is of type orders. Okay, now I can actually say order.first to get the first record. And this is the toString functionality of the case class. okay, which is generated under the hood. And if you want to access these elements, you can say uh, orders dot first dot, there are multiple ways to access these things. One is using product element and 0. So it's small over here. Okay, you can get the values. Okay, like that you can get, or you can also say order dot first dot it is of type orders, hence we can say like this. We can give the column name. What is the column name? Order ID. Order underscore ID, sorry. Okay, or order status. You can get like this. Okay, and if you see why this order ID and order status are working, any guesses here? What are this order status, order ID, etc.? Hmm? That's what are they?
Members of the class.
No, these are not members.
Class variables.
So if you look into
Class
this,
level variables.
no, the class level variables are private, so you will not be able to access. So what are they? They are the getters. There is no get like in plain old Java object. Rather, the notation in Scala is with the variable name itself. Because we have getters with the variable names, this order dot first dot order ID, order dot first dot order status, all these things are working. Now, if we want to filter, we can say orders filtered equal to orders dot filter rec, then rec dot uh, rec dot order status equal to complete of rec dot order status equal to post. We can also do like this: filter dot take of 100 dot for each println. We only give closed and completed orders. Okay, so either you can process as strings or you can also create the objects. And in my GitHub code, under code repository, there are different variations of filter. Okay, so I will give you guys some time and you can explore all these filters, and if you have any questions, you can ask me. Okay, you can go to this page and I will give 10 minutes of time. Make sure you try several combination of filter and be comfortable with that. Okay. So first, here you have to do multiple things. First, you have to read the orders. Like this. In this case, I am using as objects. and then you can apply the filter. So this is an example I have used. If you just want to process it as string, you can do that also. Here I am showing the example of case class. And if you want to create the case class, this is the syntax. In the case class. Okay, it's up to you, whatever route you want to choose, whether you want to create objects or whether you want to process it as strings. It's up to you for now to learn. But when you put it in practice, you should compare which one is performing better by going through the several factors, and you can choose whichever is performing better. Most probably, directly passing a string might perform better rather than creating an object and then reading it back. But when you process at distributed mode, it might become insignificant. Whatever overhead it uses to create those objects and all those things might become insignificant. Okay, I will give 3 more minutes. So let's get started. So we filtered the data. Now, out of once we filter the data, out of these 4 fields, going forward, we need only 2 fields. One is order ID to join with order items. Second one is order date because we have to aggregate by date. So what we have to do, once the filter is done, we have to extract for each input record, we have to extract 2 fields. The input record have 4 fields. We have to extract only 2 fields for each input record. Now, which transformation should we use? When it comes to applying transformations on input data after using text file, especially if you pass one record as input, and typically we either filter or we apply the transformation and flatten it out using flat map, or we use map to transform into different form for that input record. So out of these 3, we have to use map function. Okay, if you go to programming guide, in this case, for each input record, at individual record level, there can be only 3 transformations we can do. One is map, second one is filter, and the third one is flat map. In this case, we have to use map because out of 4 fields in each input record, we want to extract only 2 fields. So what we can do is orders map equal to orders filtered. Okay. If you want to use the string, you can again apply rec.split and extract the ones which you want to use. And also, while extracting, these two fields you cannot just extract as a string or as some kind of object. We have to extract in specific format. Downstream, we want to join orders with order items. Okay. So whatever format join expects, we have to transform data into that format. Now let us see what is the transformation we can use to join the data. There is a transformation by name join, which can be used to join the dataset. If you look at the explanation of it, when called on datasets of type k comma v in circular brackets, which means when called on datasets of type tuple with another tuple, and both of them have the common field as key, it returns a dataset of another tuple where first element will be the key which is common between both the datasets, which is already in our case, and then value is a nested tuple. The first element in the nested tuple will be from the first value from the first dataset, and the second element in this nested tuple will be value from the second dataset. Okay, so for input of these two types, we'll get the output like this. Okay. So to apply this join, we have to first transform data to this format, key value pair. Okay, hence we have to say map and then rect. In this case, each rect is of type orders. If you string, if you don't apply this orders case class, you have to say something like this, rect val orders map equal to orders filter dot map rect. If it is string, you have to do something like this. We have to generate tuple. That's why I use these circular brackets. In that, we have to say rect dot split comma 0, which will give the first field from the orders, which is order ID. As it is integer, we have to use toInt function. So whenever we want to join the data sets, we should convert it into the original format. If it is string, we have to use string. There is another option, but for integer, we have to change it to integer so that joins are much faster. Okay, and then you can say rect dot split with comma of 1 to extract the date. Already, as we have created the object, we can also say rect dot order ID will be the first element in the tuple, and then rect dot order date will be the second element in the tuple. Now you see the new RDD is of type tuple. The first element is of type string, and the second element is first element is of type integer. Second element is of type string. Now you can say orders map dot first to get the data. Okay. So this is how you can extract the key value pairs so that we can join the data. We need to identify which fields we should use. So now as and when we progress here, let me also start creating code here. So I'm saying main args array of string, and then first we have to create conf object, new spark conf dot set app name daily revenue dot set master. So here I want to create properties variable by using configuration factory dot config factory. Config factory dot load. Okay, here props dot get config. Let's say I want to pass it as a first parameter x of 0 dot get string execution mode. Let us validate with the application dot properties. Yes, it's execution mode. Okay, and then also when we actually pass the path, we will pass those as arguments, right? So here let us name it as input path, and let us give the args of 1 as input path. And here we might have to join 2 tables or 4 tables depending upon the requirement. So for that reason, instead of passing everything as argument, we'll pass the base directory as the argument, and depending upon what data we want to retrieve, we will concatenate the subdirectory in that. Okay, so in this case, in this example, we will only pass up to this as the base directory. Okay, so input path will be that one. And now I want to read orders. It will be using sc.text file. Okay, here I have to create c equal to new spark context. Okay, and then you have to give input path plus orders. It will read the orders data. Okay, and then we will apply the entire logic of first using the map function. Right. Okay. So let me paste this logic. Okay. And then I want to use filter, and okay, and then use map. This one. Okay. So now orders have the all the required data. Now let us create one more case class for order items. Case class order items. The first field is order item ID, which is of type integer. The second field is order item order ID, which is of type integer. The third field is order item product ID, which is also of type integer. Fourth field is order item quantity. Fifth field is order item subtotal. It is of type float. And then last one is order item product price, which is also of type float. Okay. So we have created one more. So again, this is not the only way you can do. It's up to you. In this case, I'm just demonstrating using case classes. You can also process them as strings similar to any scripting language. Okay. So now we have case class for order items also, which have 6 fields. Now we can read order items equal to sc.text file users IT varsity research data retail underscore db order underscore items. Okay, and here we don't need to filter anything. We just need to extract uh, 2 elements. One is order item order ID and order item subtotal. We don't need anything else. So here, what we can do is map val r equal to rect dot split. Okay, and then order items r of 0 dot 2 int r of 1 dot 2 int r of 2 dot 2 int r of 3 dot 2 int r of 4 dot 2 float r of 5 dot 2 float. Okay, and then out of these all fields we just need 2 fields. Okay, so we can apply map function again and say rect dot order item order id and rect dot order item subtotal. Only these two we need. Okay, so this is the functionality to apply the case class and then read only the required fields from there. It might not be the efficient way. We don't need to first create. Okay, I need to define the case class. I just have to save probably. It is saving.
Access those
It has come out of
Okay, got it. Yeah, I got it. Okay. So now order items have the means we have retrieved only 2 fields into the order items. This need not be the efficient way because we are unnecessarily creating map twice. You can also directly say something like this also. Let me replace this part here with input art plus. Let me put this in comment. Okay. So you can also, if you don't want to use this complicated two map statements like this, you can also say something like this. Let me take this call. Hello. Yes. Okay, tell me fast. I'm in the middle of something. Okay. Here we can say something like this: rect dot split, comma 1, because odd item already is the second element in the data set. Dot to int, and then rect dot split, comma 4, and then we have to use to float. Okay, so you can also say it like this. This need not be the efficient way of doing the things. But the bottom line is, before you join, functionally, you need to have tuples as the output for both the map functions. Okay, we can also do order items dot first to check the data. You can see the order item already and the subtotal. Okay. So here, if you look at orders app.count, it is giving 30,455. If we look at order items.count, it is giving 172,198 records. Okay, when we join these two things, how many records it should give? It should give the results between the 30,455 and 172,198, because each record can have, each order can have multiple order items, but we have filtered some of the orders which are not complete or closed. Hence, it will be somewhere between 30,000 and 172,198. Okay, so let's do the join. So here I am saying val orders join equal to orders map dot join and order items. You don't need to specify anything, as long as means like join, for joining you don't need to specify anything explicitly, because the values are already in the form of key value pairs. As part of the map itself, we took care of using the appropriate structure so that both can be joined. And you can run this command orders map. Okay, and then you can check orders join dot count, and you can see there are 75,408 records. Okay, now the data is joined, and if you say orders join dot first, you can see the element is of type tuple, the key is of type integer, or first element in the tuple is of type integer, which is order ID, and the second element is tuple. The first element of this tuple is order date, and the second element from orders, this is from orders, and the second element is order item subtotal from order items. And you can see the results, sample result here. Now, what is our requirement to get the revenue by date? To get those two things, to get the revenue by date, we just need these two things. We don't need order ID. Hence, we can discard the order ID. So for each input record of this tuple, we just need this tuple as output for each input record. So which transformation we should use? Again, we have to use map function, map transformation. Okay, and then here we just need to read this. How can we read this? So for example, it is like this: val r equal to okay, and it is of type tuple, and to read the key we just have to say r dot underscore 1. In this case, we just have to discard this, and we want this entire stuff. So how can we read that as part of our map function to extract the tuple? Any guesses online? r dot underscore 1 will give this one, and we need this. How to read this from this? I hope people are not sleeping. Okay, wiki is there. Good. R dot underscore 2. That is correct. The reason why I'm explaining this is when you develop, you should use REPL very effectively. You should be able to produce the scenarios quickly using REPL, and then use the REPL effectively to come up with the code which you can embed or use as part of your main program. Wiki is correct. R dot underscore 2 will give the tuple. So now on the orders join, I'm applying the map function. So orders join dot map. Okay, I can just say underscore dot underscore 2. Okay, now you see each element of this RDD is of type string and float. I can say orders join map dot first update of 10 or 100, whatever it is. We can see the sample data. Now the output of this map function is a tuple, and we need revenue by day or revenue per day. Okay, so which function we should use? Either we have to use group by key or reduce by key or aggregate by key. But in this case, we are trying to do aggregation. With respect to aggregation, group by key does not use combiner. So rather than using combiner, reduce by key, so rather than using group by key, which does not use combiner, it might be good idea to use reduce by key because it uses combiner. But we will see syntactically how to use group by key, how to use reduce by key, how to use aggregate by key. All the three scenarios we will see. Okay, so that you get more familiar with these transformations. So here, orders join map. If you want to do it using group by key, you can say group by key here. It will create a tuple of type string and iterable. And if you want, you can do the count. So if I say orders join map dot count, it will give that 75,408, whatever was the number earlier. And then if I do group by key and then do the count, now it should come down to the number of orders, which is around 30,000, because each element after group by key is of type key and value pair. Keys are all unique after group by key, and values will be all the elements which will be converted to list. And if you do count, okay, here, here we should not think from the orders perspective. Here we have the date as the key. Okay, so the data set has 1 year worth of data, which is 364 days, and hence it has written 364. Because we have 364 dates, which is key, we got 364 here. And again, if you remove the count and see the data type, it is of type tuple. The first element is date, which is of type string, and the second element is a collection of float. And now you can actually run take of 10 for each println to see the output. You can see for this date, these are the odd item subtotals for different odd items. Okay. And now if I want to add these things after group by key, what I can do? Shall I use map or flat map? Or some by key operation? Which one should I use? Map or flat map or some by key operation? Here the requirement is for this input record, which have key as data as key. Sorry. Which have data as key and collection as value. The output should be the date, which is again key value pair. The key being the date, the value being the sum of these elements. some of these elements in the array. So which transformation should I use on group by key?
Someone.
Which transformation should I use?
Map.
We should use map. Okay, guys online, have you got it? So for this structure where the key is the date and the value is collection, we want to generate a key value pair which have date and the value is sum of these things. So for one input record, we are getting one output record. Hence, we are using map function. So first to make sure that it works as expected, you can actually create a tuple. Okay, I am passing the date as key, and then we can say array. These are all floats, so we don't need to put in double quotes. It's very easy to reproduce. You just paste the things, and now you got the sample tuple to explore your Scala based API calls to get some of these things. Okay, so now if I give r dot underscore 1, it gives the date. R dot underscore 2, it gives this the element, the entire stuff. Now I want to get the sum of these values, and this logic has to be included as part of the map function. So to get the sum, we just have to use r dot underscore 2 dot sum, and it will use the sum. Okay. So to implement the logic, it will look like this. So if you want to create the tuple, you just have to say r dot underscore 1 and r dot underscore 2 dot sum. Hey, if you give reduce, you have to again give the underscore plus underscore, or yeah, you can use reduce, but sum is enough for this scenario. If you want to get minimum revenue or maximum revenue, you can use min or max. Okay. So these are all Scala based APIs. So 599 is the maximum revenue for the day. Minimum revenue is this one, 1998. So you can try these different Scala based APIs. But for our purpose, this is the logic which we have to use. So here, order join map group by key map rect implies rect dot underscore 1 rect dot underscore 2 dot sum. That's it. Okay, then you can actually say collect for each println. Okay, now you got the data, and if you want to sort by this date, again you should go to the transformations, and there is a sort by key which takes key value pairs in the form of tuple, and the data will be sorted by this key. Okay, so we can use, before collect, we can say sort by key, and then data will be sorted by date. Okay, so this is how you can implement. Now let us test it out on the cluster and see how it will perform. Okay, so I'm logging into the cluster now. We don't need 16 executors, so I'm just removing this one. This is very small data set. So we'll break at 355. for 10 minutes. Okay, now I will define, we don't need to create configuration and context here. We can directly say input path equal to, this is the common path where everyone have access to, public retail underscore db. This is the base directory. Okay, and then I am creating the case classes. Okay, once the case classes are created, I can directly run this code. Okay, now orders and order items are created, and then I'm saying daily revenue group by key. Okay, here I will club multiple transformations in one. So orders dot join order items dot group by key dot map rect implies rect dot underscore. Oh, okay, just okay. First, sorry, there is something wrong. So first, I need to discard the order ID and get the date and subtotal. So here I have to first use map function, and then rec implies rec dot underscore 2, which will give the date and subtotal, and then group by key, and then map again rec dot underscore 1 rec dot underscore 2 dot sum. Okay, and then sort by key, and then collect, and then that's it, collect. Oh, I have the dot already, that's fine. So I will copy only till the map function. Okay, and then sort by key. Okay, once you run the sort by key, so sort by key generate the shuffled RDD. That's why it actually ran internally. Okay, and now you can actually say daily revenue GBK dot collect dot for each println. Now you got the data. Now if you go to the browser, and I'm going to RM018088, which is Resource Manager Web Interface. And here, this is the one which ran. And you see, this one execution actually created two jobs. Okay, because if you look at the program, what I'm doing, first I have created the case classes, then I have processed orders and order items, and then I joined and then applied the GBK, and then I did sort by key. That is, so here group by key will create, actually sort by, my statement was incorrect, little bit incorrect. Earlier what I have mentioned, whenever it says action, it will create an additional job. That is partially true, and some of the transformations also create additional jobs. In this case, sort by key is one such transformation where it will trigger one more job for the subsequent step. So up to sort by key, it has run as one job. If you click on this, you can see the DAG, and here this is reading order items because there is no filter in it. If you want, you can click on this and you can see what this stage 0 is doing. So it is actually reading order items. And as part of the stage 1, it is reading orders, applying filter. Where is the filter? Map. Yeah, sorry, map, filter, map. Here is the filter. Okay, and if you go to the next stage, it is taking the output of these two stages. Join also create a shuffled RDD. Okay, that's why it has created one more stage. And in this case, each text file invocation created one stage here because it is trying to read two data sets from the source. And then join is created the third stage, which will create the shuffled RDD. Hence, it has created the third stage. After that, we have applied the map function to discard the key. And then group by key again creates the shuffled RDD. That's why it has created one more stage here. And then map and then sort by key. Sort by key is kind of a special transformation.
Because we used correct in different statements.
No. We didn't use correct here. We just said sort by key and then next we invoked the collect.
Yes.
Even if you gave save as text file, even then you will see two jobs. Okay, so up to sort by key, because it has to sort the data of whatever it is, it has processed data as one job. And then it has triggered one more job. I will come back to that question in a moment. It has triggered one more job wherein it is actually lot of stuff is actually skipped and only this map and collect are executed. Okay, here it is saying in 7 it is saying map shuffled RDD. I don't know why it is executed twice. Anyway, that's fine. We don't need to worry too much about it. And then I think because I know why.
And it is caching that result.
Yeah, it is reading from the cached result. That's why it is showing like this. Okay. So as part of this, it just read the cached result and it just printed it. Even if you use save as text file, you will see the similar DAG. Okay, so this job actually created two jobs. So this application actually created two jobs. And primarily, if you look into this, now let us get into the performance difference between using group by key and reduce by key. If you see, this third one is generating the shuffled write of size 459 KB. Okay, and then that 459 KB is passed on to a map function to aggregate further. Now, if I run reduce by key using reduce by key rather than aggregate by key, sorry, group by key, if I use reduce by key, let us see what will happen. Okay, so here I will give RBK. And here there is no difference. We have to get date and revenue. And instead of group by key, here we will say reduce by key. Okay. And then we can say underscore plus underscore sort by key. Okay. And then you can say daily revenue RBK dot collect dot for each println and hit enter. Now the data is returned. And if you go back here and click on jobs, again it has created 2 jobs. Okay, and if you click on this sort by key, you see data of the map output has passed to reduce by key here, and as part of the reduce by key we directly aggregated, and you see the shuffle right is only 8.7 kb rather than 400 kb because it uses combiner internally. Reduce by key uses the combiner, whereas group by key does not. Okay, so that is the performance difference. Even with smaller data set also you can see the difference if you keenly observe it. Okay, so in this case we should use reduce by key, not the group by key, because we are trying to aggregate the data. We will see the relevance of group by key later, and let me finish this reduce by key logic which I have tested just right now, and then we will take the break.
Both and you can put it in.
What is that?
I was saying like you can put that group by key also and put it in list. Maybe that comment. Then
Yeah.
comment out.
Not sure whether I will put it in gist because I have the code in gist already. I will be
But
providing
it
the
is not with
same.
case class.
Yeah, that's correct. Actually, case class is not required in this case for this example. So if you want to implement using group by key, just if you want to example with the group by key, I'm just pasting it here. Code. Okay, this is the group by key, and you can say daily revenue rbk dot select dot each println. Okay, so we'll take 5 minutes break, and we will catch up in 5 to 6 minutes. Okay, and then we'll continue. Then we will also see the relevance of group by key, and we will wrap for the day. Okay, sorry, Vicky, I hope you are still there. Let me take your question. We didn't specify any key. How it will identify the key? So, where are you lost? Is it with respect to join, or is it with respect to reduce by key? Where is the confusion, Vicky? I think he is not there. We'll catch up in 5 minutes. Raju Sagi just joined. Just give me 5 minutes. We are taking break, and then we'll continue after 5 minutes.
Monday ఉంటుందిరా
So Vicky, are you back? If you are back, I will answer your question. Let us proceed. Okay, now we see the syntax and the usage of reduce by key. In the same session, now we will try to use group by key instead of reduce by key and see if, the difference with respect to syntax and also the performance. Okay, so here I'm naming it as daily revenue aggregate by key, ABK. Okay, then here there is no difference. Now, for using aggregate by key, so aggregate by key requires two anonymous functions at least. Okay, and if you go to the syntax, here it is a little bit complicated to develop. You can see the syntax aggregate by key, and then you have to give two brackets like this. The first bracket you give initialization value, which is called as 0 value, and as part of the second brackets we have to at least give two lambda functions or anonymous functions. One is for combiner logic or sequence op. In terms of Spark, they call it a sequence operation. And in terms of Spark terminology, the final implementation is called as combine op. Whereas in terms of original MapReduce, this is called as combiner logic and this is called as reducer logic. Okay, so we need to give syntax like this: aggregate by key, and then two circular brackets. As part of first circular bracket, what we have to give? We have to initialize. And how we should initialize? It depends upon what we are returning as the output. If you go back, what we are passing as input, we are passing the date and the order item subtotal, which is of type tuple, string, and float. So this is the input type which we are passing to this aggregate function, and the output type is also of type string and float, order date and aggregated revenue, right? So to get the so the data type is still float. Okay, so we need to initialize this to a float value, whatever is the final output. So if you really think from Scala perspective, let's say you have a list of array and you have 1.0, 2.0, 3.5, 10.75, etc. Okay, so this is list of a array, and if you want to add all these values in conventional approach, how it will be? You will create a variable like this, mutable variable like this, total equal to 0.0. Okay, here it is using as double by default. If you want to create as float, you can say yes. This also, if you want to create the float values, you can give like this. Okay, and then how we will do? You will say for, if it is Java, you will say element and then C. C is of type. C will be of type collection, and element is of type the type of the element in the collection, which is, so the data type of this will be double and float, and this is collection of float. Okay, so then you will loop through it saying this total plus equal to element. And finally, total will have the final value. If it is Scala approach, you will say, let's give the name as E, and then you have to use less than symbol with minus, and then collection, and then you can say total equal to total plus E. So this is traditional way of programming, and then you can say total, and it will give the sum of all these values. Okay. So now, if it is of type integer, the total also has to be integer. If we have more complex type, for example, val c equal to array of 1 comma or hello comma 1. I am creating the array of type tuples. World 2, 3, 3, 4, 4, and hit enter. Now the collection is of type array, and each element is of type tuple, string, and integer. Now, if I want to um, uh, add these things, I want to concatenate all the strings and add the numbers and get finally hello world 3, 4, and 10 as the final result. How I will do? In traditional way, I will create a total of type something like this, right? So it is of type string and integer, it's a tuple. And then for each element from the collection, what I will do, okay, let me give it as var. Okay, and then I can say, let me do this, let me write it in multiple lines because we have to concatenate the strings separately and numbers separately. So what I will do, total dot underscore 1 plus equal to e dot underscore 1. Okay, and then total dot underscore 2 plus equal to e dot underscore 2. Equal to total dot underscore 1 plus okay, I understand. So each element is of type immutable variable in the tuple, that's why it is complaining. So here, let me try this. I'm not sure whether this will work or not. Okay, these are all immutable, and that's why it is not working. Let me, yeah. It is immutable, that's why it is not working. Otherwise, it would have worked. That is fine. Okay, we can ignore it, but no, even though you are defining it as var, I think the nature of elements in the tuple is immutable. Each element is immutable. There should be a way. I'm not sure. There could be a way to make it mutable, but we cannot update the existing tuple. Internally, Scala is smart enough to use immutable variables and still compute the count. But this is how it will look like. If it works, then finally, if you type total, the first element will give hello world 3, 4, and the second element will be 10. Okay. So the bottom line is, depending upon your final output, which you are trying to get, your total variable should be initialized, and that is what we have to do here. Okay, if the final output value, if the final value type is of type tuple, you have to initialize it to a tuple. If it is of type float, you have to initialize to float. If it is of type integer, you have to initialize to integer. And then here we have to give two functions. The first one is combiner function. Second one is reducer function, the final function which will add the intermediate values. So here we have to create a tuple again for the intermediate totaler or aggregator and the intermediate each individual value. Okay, so here we are let me name it as T and then V. Okay, now you have to understand the data type of this T and V. Okay, so data type of this V is whatever type we have used to initialize, which is nothing but the type which will be the final type of the final value, which is of type float. And in this case, the aggregator type, sorry, V is of type element which we are trying to add, and T is of type whatever we have used to initialize, and also the final value which we will get. Okay, so here T is of type float and V is of type float. Okay, so to get the intermediate values, we just have to say T plus V. Okay, and then second function, which is reducer function, we will say T1 and then IV1, intermediate value 1. Okay, and in this case, both are is of type float only. We just have to add these things. In this case, we don't need to use aggregate by key at all. We can use reduce by key just to explain you the syntax. How you have to write aggregate by key. I am taking this example. We will see another example where these two will be different, and I will explain further at the time also. Okay, so aggregate by key is done. In this case, this logic and this logic is same. Okay, and then we can sort, do the sort by key the way we have done earlier, and hit enter, and then you can say daily revenue abk dot collect dot for each println, and hit enter. Now you see the data, you got the results. And if you go to this again, and if you click on jobs, we are running all the things in the same session. This also actually ran in 2 jobs. Okay, and if you go to the DAG, it is exactly similar to reduce by key, except that here it is using aggregate by key instead of reduce by key. And if you see the output, it is exactly similar to reduce by key. So functionality wise, unless the combiner logic and reducer logic are different, you should not use aggregate by key. It's like unnecessarily complicating the stuff. Only in the case of combiner logic and reducer logic are different, you should use aggregate by key. Okay, so now the output will be the same, but the syntax is a little bit different. The performance also will be the same when you use aggregate by key versus reduce by key. Now we will take a little bit different example. So instead of getting only the total revenue for each day, let us say I want to get the total revenue for each day plus total number of order items for that day. Okay, so if you go back up to here, where we only apply math function but does not apply aggregate by key. First, we need to preview the data here. Daily revenue ABK dot you can say take off 100 for each println and hit enter. You see the data type is of type tuple. The first element is date and the second element is order item subtotal for each order item. Okay. Now using this as input, I want to get output as date and then yes a tuple as value where we have the revenue for that day and also total number of orders for that day. In this case, you cannot use the same logic for combiner or reducer as it is. If you there is another way where you can use reduce by key for this scenario also, but given this input, we want to generate the revenue for each day and also total number of order items for each day. In this case, we have to use aggregate by key. Now closely follow it because this will actually explain the syntax difference and also I will try to explain how to write the aggregate by key logic. And it is very important to follow. It's a little bit complicated. Aggregate by key is one of the complicated aspects in the Spark. Now I'm using the same. Sorry. So this one will generate output like this. From here, I want to use the aggregate by key. Here, this is key. We typically do not deal with keys once we use by key operation. Okay, this by key operation will be invoked once for each key. Okay, and the value type is float. But finally, what we get, what we want to get, we want to get a tuple as value, which includes revenue as well as the number of items. Okay, so here, as part of the first brackets, as I have mentioned to you earlier, depending upon the final output, your aggregator should have the should be initialized. So in this case, our final output is of type tuple. So we are creating the double brackets, and the first element we want to store the revenue, and the second element we want to store total number of records, and then we want to define the first function, which is the combiner op or sequence op or combiner logic. Okay, now start the complicated part. So here I am giving the name as aggregator. Okay, let me name it as sequence aggregator and then value. Okay, now you need to understand the data type of these two. Okay, so this value is nothing but element. What is the data type of the element? It's float. Okay, so these values are nothing but single element float. The data type of this value is just float. What is the data type of aggregator? Whatever value we have used for the initialization. Okay, so it is of type tuple. And where out of this tuple, which is initialized to 0.0, comma 0, which one we want to store, which position within the tuple we want to store the revenue, the first element. Okay, so we have to add value to sequence ag dot underscore 1. Hence, we have to use this one, and this has to be tuple. So we have to give it in the circular bracket, and then the second element of the tuple, we just want to add the items. Hence, I am using sequence ag dot underscore 1 plus 1. Okay, so let me do this. Let me print the intermediate results. Okay, here I am writing this this logic in multiple lines. Okay, so here I am creating C equal to sequence ag dot underscore 1 plus value, and then yeah, ag dot underscore 2 plus 1. Okay, and then I want to print C, print ln C. Probably in cluster mode it might not print, but we'll see. In local mode it will print. But here I am running in cluster mode, so we will see. And then I want to return C finally, so I want to just use C here. And this conclude the first lambda function or anonymous function. Now final total. Okay, it's combiner aggregator and combiner value. So combiner, both are of type tuples here. Okay, and the first element of the tuple for the combiner aggregator is initialized to 0.0, and the second element of the tuple is initialized to 0. And this will actually give the intermediate values, some intermediate value, depending upon when the combiner invokes. And here we have to add first element of this tuple to the first element of this tuple, and second element of this tuple to the second element of this tuple. Okay, so let me write the logic again. Logic here. Again, I am creating a new variable so that tag dot underscore 1 plus combiner value dot underscore 1 combiner ag dot underscore 2 plus combiner value dot underscore 2, and then println. It will be printed for each iteration. So let me inside combiner of plus C, and finally I want to return C. Okay, this will conclude the second anonymous function, and then we have to close the aggregate by key function. Now, the syntactically it accepted it. Now, if I run daily revenue apk collect, let us do collect for each print ln. Okay, it is not printing because, as I mentioned to you earlier, I am running it in the cluster mode. It will not print in cluster mode. So let us try to run this locally also. Okay. Idea projects, SMS. Yeah.
Scala.
Mm.
For that, Scala is beautiful service.
No, this is also not the one. This is also on the cluster. Otherwise, it would have generated the logs. Okay, so let me run this. So here I'm creating the class orders and order items. And then local. Okay. Okay, I copied you in unnecessary stuff. That's fine. Now let's run this aggregate by key logic. Okay, now let me run. What happened? Every path might be incorrect. Let's take up 10, 8. That is not correct. Path is not correct. So let me take, okay, I know what is the problem. The input path I set it to arcs of 1 right in between. That could be the reason. I have to run it again. Start. Reverse cytosity research data. Retail DB. Order start. Take off. Order start first. Order items. That's first. Okay. Empty collection. Okay. Empty key. Empty collection. Okay, sometimes I have to do this. Sorry for wasting the time. Let's try it again. And if it does not work, we will proceed further. Okay, import arc.apache.spark. Underscore, and then I'm creating the conf object. Okay, now I have to copy orders data, order items data. Okay, so daily revenue vk dot collect dot fetch println. Yeah. Now we got the result, and you see, let's take the example of one order rather than running for everything. Let's take the example of one order or one date. Okay, and we will see what is happening.
Take this
No, no, take will not work. So if you want to see how it is being adding, you should actually pick one date. Okay, so let me copy this one. And this approach will only work in the local mode to validate. Because in distributed mode, when you try to print, it doesn't know where to print. It is not running locally. This functionality is running in distributed mode on some cluster. So these println commands will not make any sense if we are running in distributed mode. So here, before joining, I am actually saying orders.filter, and then rec dot underscore one equal to, I have to give the date. Which date we will give? We will give this one. Okay, and then let us run this. Rec dot underscore one. Comparing values of type int and string using equal. Okay, I got it. Orders, I understand. Here it has to be rec dot underscore two, not underscore one. Okay, now I can print only for one day. It will give you idea about how the aggregate by key is working. Why it is only giving one? Okay, it is running on cluster. Sorry. Now I can run on this, and now we can actually validate. Yeah. Now you see. So as part of the combiner, it keep on adding. Okay, and this is the combiner or sequence of logic up to here. Okay, it keep on adding up to 215. In this case, it does not invoke um, the combiner and reducer separately. So there are no intermediate values computed. That's why you are seeing everything as one result. Because there is not much of data, I'm not able to produce it. If you have enough data, as part of combiner logic, you will see bunch of intermediate values, and those intermediate values you will see finally and you will see reducer being invoked, and you should have seen this also inside combo uh, uh, as well, but it did not show because we don't have too much of data to generate those intermediate values and the final values separately. So that's why the behavior is not as expected. Even in this case, okay, let me see. Even in this case, it did not. So this println is not okay. I think I understand the problem. I think this is not the way we can validate. It is invoking the combiner for sure. That's why you can see, okay, we are running in local mode. Anyway, that is fine. I'm not able to produce it to show the data. Um, as long as you understand the syntax, I think we are good to go. If you have any questions with respect to aggregate by key syntax, let me know. I will reiterate again what I am trying to do as part of aggregate by key. Okay, so these println commands and all should not be there. So I'm removing these things so that I keep it clean. Okay, now if you see, as part of aggregate by key, first we are initializing uh, based upon the data type of the final output, which is tuple. In this case, first element will be storing the revenue, second element will be storing the count of order items for that day. And as part of the combiner logic or sequence op, we are passing tuple as a parameter, and out of this tuple, the first element is of type tuple, whereas second element is of type the input data, input value, which is float. Here, for the first element of the tuple, I am adding the revenue for that order item. And as part of the second element of the tuple, I am just adding a hard-coded value 1. Okay, because we are iterating.
Sequence add is a tuple of total, both, right?
Sequence ag is of type tuple. First element of the tuple is of type float, which will be used to store the final revenue. And second element of the tuple is of type integer, which will store the final number of order items for that day. Okay, so here let's say you have data like this: d1 2.0, d1 3.0, d1 4.0, d1 5.0. Okay, this is the input data, and here the aggregator, the intermediate aggregator, is of type tuple, and this will be invoked 4 times. But output can be either 1 value or 4 values or 2 values. Each one of them can be result of these two, and result of these two, or one can be the result of these 3, and other one can be result of just this one, or it can be any combination. It will generate the intermediate values. So this logic will actually generate the intermediate values. Let's take the example of generating 2 intermediate values. So what will be the output of this after adding this? So let's take the first iteration. For example, as part of the first iteration, to 0.0 comma 0, we are adding 2.0. Okay, so what we are trying to do, we are fetching the first element and then adding the 2.0 to that one, and then comma 1, which is a hard-coded value. As part of the second iteration, let's say we are adding to this and then generating the intermediate value internally, not explicitly like this, but internally. As part of the second iteration, probably this will have 2.0 comma 1, and we got the value 3.0. We are adding hard-coded value 1, and after this iteration, it will be 5.0 comma 2. Okay, so this might generate something like this: 5.0, comma 2, and then 9.0, comma 2. Okay. Now, as part of this, we are trying to add these two. And when you add these two, finally, what it will give? It will give 14.0, comma 4. Whether you add these 4 elements separately or you add by computing intermediate values as part of the final step, the final outcome will be the same. Okay. With aggregate by key, your sequence of logic and the combine of logic can be different. With reduce by key, they both have to be same. Okay. So only syntactically there will be difference. Otherwise, everything else is same between reduce by key and aggregate by key. Okay. So is it clear? With respect to aggregate by key, this is one of the complicated part. You have to practice quite a bit to digest this. You will make a lot of typos and all those things while practicing, but if you practice enough, you will get it straight into your head.
Second
Okay.
part of the logic will have both tuples, whereas first one will have only sequence as
Yes, aggregator will be of type tuple, and this
value
one
is not a tuple.
it is depending upon the data type of the input data value. Okay, so input data value is of type float here. That's why value is also of type float. Okay, now for this example, we should use reduce by key. Pretty straightforward because we are only getting the revenue. We are not getting the number of items. But if you want to get the number of items, you can use aggregate by key. Finally, I want to store it into an output path. Okay, so I can delete this one also. We don't need these things. I don't want to even create the variable. Here, the output I want to store should be in the format of tab separated values. Hence, we have to use map function once again. Okay, and then you can say rex dot product iterator dot mk, and I want to give tab as the delimiter. Okay, and then I want to save it into the file format. Save as text file. I have to give output path. Okay, so here I have to create a variable called output path, which is equal to args of 2. And on top of it, whenever you are actually passing this input path and output path, you have to perform some validations. For example, if the input path does not exist, there is no point in trying to execute, and you have to throw some graceful exception. Similarly, if it is output path, so far we are giving the unique directory names, but in reality, you might have to create the directory name uniquely on runtime, or you have to overwrite. Typically, these two are the scenarios which you will which you will implement. Either you will create a unique directory every time you run the job and put the data into that instead of failing that directory already exists if the directory already exists, or you have to delete the existing directory and recreate it. So here, to handle those file system related stuff, you need to understand few HDFS Hadoop related APIs, because Spark does not have underlying file system. It does not have its own proprietary file system based APIs. Instead, it uses HDFS APIs extensively. So in this case, you need to have a good understanding about HDFS APIs to gracefully handle this type of issues. Okay, so when it comes to certification, this is not very important. But when you try to implement as part of your projects, you will come across these situations, and you should know about this very, very important package called arg.apache.hadoop.fs. Okay. If you go to the official documentation, let us go to the API docs. On this one, there is another. On this one, Hadoop API docs. Is this the one? Yeah, this is the one. Okay, so this is the link which you can use. And in this, under org.apache.hadoop, there is a package called fs. Okay, you can click on this, and if you see, there are many sub packages under fs. So all Amazon related stuff will be using these S3, S3, S3 native APIs. When it comes to Azure Blob, Microsoft Azure Blob, it uses these sub packages of fs. But the main package is org.apache.hadoop.fs. Here there are several subclasses. So if you want to, if you give a parent path and if you want to filter out some of the unnecessary paths and only consider certain things, you need to use API called path filter. And over a period of time, you should be able to figure out appropriate APIs which you need to use. To limit the scope, I will only focus on file system and path. Okay, these two are the classes which we will be using. And to copy the files into HDFS, typically how will we copy the files into HDFS? We have commands such as okay, here you need to use something called Hadoop FS, and it has several subcommands which starts with hyphen. And out of these commands, you should know especially copy from local, copy to local, where you want to copy files from the local file system into HDFS and back and forth. If you want, you can explore ITversity channel and you can search for HDFS related videos and you can see all these commands in detail. So this is nothing but command line generated based upon Java based APIs, and the class which will serve those APIs is primarily file system and few other classes under FS package. Okay, so understanding this file system package can give a lot of flexibility for you while you are on projects. Okay, so here we have to use this one for different purposes. If you want to, let's say, create a directory in HDFS with some name on the fly, which is unique or system generated at that time, there should be a API called mkdirs make directories. You can give the file system, the directory name, and the permissions also. So like that, you can go through this list and you can understand whatever you want to do programmatically. You might have to use file system and on top of it some other APIs. Okay, so to use this as part of your program, even for the validating whether the path is correct or not, whether if you want to delete a directory if it is already existing, in those cases you have to understand how to integrate the file system API as part of your program. Okay, so to use these things, first using the Spark context object, we have to get Hadoop configuration because we are trying to deal with HDFS related stuff. Once we have to get the Hadoop configuration, we have to assign this to some variable. On like c.hadoop configuration. Let me see. Yeah. So you have to pass this Hadoop configuration, and then you have to create the file system object by using file system.get. File system is a so let me create the file system object. This is how you should create file system. Is HDFS based class. Here we have to use file system that is related to org.apache.hadoop. You should not use the first one, which is related to NIO. You have to use this one. And then it has get, and using Spark context, you have to invoke the Hadoop configuration. And using that, you can get the file system related stuff. And then you can add type annotation to see the data type of this. This is nothing but file system itself. So FS is of type file system now. Now, all the APIs related to FS are exported, and you can use it as part of your program. So here, let's say first we want to check if output path exists. So if new path, and again here we have to use org.apache.hadoop.fs, okay, and we have to give the output path as the parameter. It takes the string and it will create the path object, okay. I know. And you can say dot okay. You have to use fs dot exists, and that actually takes the path type, okay. So from the string I have created the path object, and I'm passing that path object to fs dot exist to check whether it exists or not. If it exists, then what I want to do, I want to delete the path, which is output path. Okay, here I have to give some type of. And also this one is deprecated. There is another one which is supported. We just have to use true here. This is the valid function. So this will actually check if the output path exists. If it exists, it will delete. So let us create a separate object for this instead of invoking new path twice. Okay. Val op equal to new, and then I just want to delete. Okay. And also when it comes to input path, I want to see whether the path is valid or not. And if the path is not valid, I just want to throw an error. So if fs dot exists, in this case I want to check for the negate condition. If the path does not exist, then I want to throw an exception. And then here I have to say new path, input path, int ln. You can handle the exception if you want. I'm just saying invalid input path. Okay. And out of this, and this is called as driver program, right? And out of these things, you should know which part of code will be running in distributed mode and part of the code will be running in driver. So, except when the transformations and actions are used, everywhere else the program will be executed as part of the driver. Only when you are using Spark-based APIs in the form of transformations and actions, it will run in the distributed mode on the cluster. So in this case, all the validation first happen at the driver level, then it will actually go to the cluster and submit these transformations and actions in the form of jobs. Now we have completed the development of the program. Okay, and we can build the jar file out of it, and we can ship it to the cluster, and we can run on the cluster. So I will give you some time here. I will paste this code. Let me see if there is existing code. You can use that code. No need to just follow what I have. Whatever we have in the gist, you can use that also. Okay. And if you go to my gist account, and if you want to search a particular thing, what you can do is you can just go to gist.github.com. You don't even need to go to my repository. You just say user T Gadiraju and then slash and start typing the uh, name of the program, daily revenue. I don't know. It behaves a little bit weird. Okay, now this one. They are not. I think the search functionality is not good. Yeah. Anyway, I will give you the link directly. Okay, I think I do not have. I have a lot more complicated example in this case. Daily revenue per day per department. I do not have the just the department stuff. So let me copy to the gist. New gist. Spark Scala daily revenue dot Scala. Okay, so you can use this one. Application.properties. I think I have shown as part of the last session, right? So you should be able to use that one. If you continue, if you have developed the program last week, it is addition to that. Okay. So now you are good to go. You can use this one and make sure you make the necessary changes and compile it at least in the IntelliJ. If you want, you can validate. Let me validate this program locally and see if it works. Then I will give you time. So here I just have to go to edit configurations because I have to pass the parameters. Okay, so it did not identify these order items automatically. Hence, we have to click on plus here. Yeah, plus and then application. And then you can give the name daily revenue. And then you can actually pick the main class here. So here I'm trying to use this one. Don't type, just use this one and pick the correct one. And the program arguments, I want to run in dev mode, users, IT University, and then research, data retail underscore DB. Okay, and the output path, users, IT University, research, data, daily revenue. Okay, and then you have to choose this class path for module and use the appropriate program, and then click on apply. OK. Now if you click on run daily revenue, it will run in the local mode. Let us see if it works. Okay, it seems it did not throw any error. Now if I go here, cd research data daily revenue -LTR, you can see the data here, and you can see the revenue for each day. Okay, so it is working without any issues. Okay, now you can use this link which I have pasted and set up in your PC. And then I will give 15 minutes time for this. And then I will show how to ship to the jar file. Okay. It's, I think I will show. I will add it to the gist itself. Okay, let me add it to the description. Git code for daily revenue. Okay. Okay, now let me add that aggregate by key logic also. I need to figure out where it is. Yeah. Let me use this one only. So while I'm fixing this, you can proceed and you can try integrating with your program, existing one. I'm updating the gist. So now it's 5:10. 10 more minutes, and by 5:20 you should be able to integrate. If you have any issues, let me know. I will try to fix those things before we move to the next important topic, group by key. Okay, I will probably leave it as an exercise for you to run this on the cluster. I will not be covering those things. You just run it on the cluster and see the behavior. That you can do it probably tomorrow. And if you have any questions, you can write those things on discuss.itverse.com, and I will try to respond to you. Okay, but make sure you create the program at least locally, compile it, and then run it locally using IntelliJ. And then tomorrow you can take care within the cluster. At 5:30 I will start, or 5:20 I will start talking about group by key. Group by key is very, very important. And as part of covering group by key, we will actually see sorting and ranking quite extensively. Okay, and then we'll wrap up.
Not showing that update Apache that build system package. They show only like
Uh, you can import.
that is already there.
Yeah, as it is already added, it is not showing up.
It is showing like red symbol and
Okay,
showing what
okay,
is up.
okay. Yeah, then there is some issue. Show me your build.spt.
It's not.
Yeah, you haven't defined this Spark dependencies.
Created new package as
Okay, okay. New application, you create a new
well. New
project.
project complete.
Okay, okay. Then you have to update type safe config. So what will be the topics on next Saturday? Next Saturday we will be covering Spark SQL and Spark streaming on top of whatever is left over from today. So if you go to Spark programming guide and look into transformations and actions, So I have covered map, filter, flat map, and then join, group by key, reduce by key, aggregate by key, sort by key. Group by key, we have to see real examples where group by key should be used. That will take enough time. We have seen coalesce also, but other transformations are also important, but I will not be covering those things. You can practice, and if you have any questions, you can ask. Most of them are self-explanatory. And then as part of actions also, we'll be covering most of the stuff. So if there are any important things that will be missed out, even after 6 today, I will be covering those things as part of the next Saturday. And then I'll be covering Spark SQL and Spark streaming. So 4 more minutes. If you are running into any issues, and if I have to troubleshoot, I will spend more time and I will troubleshoot those issues and make sure they are resolved. Otherwise, we will go ahead with group by key. Okay. I don't know who V is. V is done. Okay, okay,
Division.
okay. Okay. If you don't mind, I think you are updating the existing GitHub code, which will be of previous workshop. It will be better if you create new directory for this workshop. No, it's not GitHub, it's a gist. Okay, so you don't need to worry about it. And I'm not overwriting all the things. Most of the examples, in which case it is same. If there is additional thing included, I'm just updating it. If there is few lines of additional code, so it is being taken care. Most of the things I'm creating new, and some of the things I'm referring the existing ones to you. Okay, and also on top of this, we will start in a moment. If you want to do some exercises, you can go to discuss.itversity.com, and in that you can go to the main category big data, and there is a category called workshop exercises. And if you go here, there are in the 0 series, we have set up development environment as one exercise, develop and run word count application is another. One interesting one is political analysis for the state of UP. Another one is develop Scala based application using JDBC and TypeSafe config. Another one is develop word count program using Scala IDE. Develop Spark application using Scala to get daily revenue per department, where you have to join 5 tables to get the aggregation. And then there is another important thing which is missing, that is accumulators and broadcast variables, which I will be covering as part of the next Saturday session. Get top and trend stocks by volume each month from NYSE data within a given year. All these exercises work, and then Spark SQL for both 5 and 6. You can actually go through these things, and if you want to develop programs for these exercises, you are free to do so. And if you have any questions while doing that, you can either, if it is related to the incorrect information as part of the exercise description and problem statement, you can write that on the topic itself. If it is generic question with respect to Scala or Spark, you have to create a new topic, and under category Spark in big data, and you can write the topic, and someone or other will respond to you. Okay, so big data and then workshop exercises. Now we will get into the, so far from business requirements perspective, we have seen how to implement cleansing of the data using map or flat map, standardization, cleansing, all kind of row level transformations. We use map or filter map, flat map. If you want to discard some data while processing, we use filter. And then we try to see the aggregation examples where we have used reduce by key and aggregate by key, along with group by key also from syntax perspective. We have seen how to join the datasets. And one of the very prominent use case is sorting and ranking. Okay. So when it comes to sorting and ranking, there is a concept of global sorting and by key sorting. Let's take the example of what is global sorting. Let's say there is a retail store like Big Bazaar in India, where there are hundreds of stores across the country, or even thousands of stores across the country. If we want to see the top to bottom stores by revenue generated within a year or so, so first we have to aggregate the revenue generated by each store, and then we have to sort in descending order by the revenue for the time frame. It is kind of a global sorting. Okay. Now that is the example of global sorting. Anything where we have to go through the entire data set and sort the data in ascending or descending order, it is called as global sorting. If you want to rank, for example, out of all the stores, if you just want to get top 10 stores, it is called as global ranking. Okay. And then by key sorting and by key ranking. when we say by key sorting and by key ranking, if there are 29 states in India, I guess 29 or 30. I always get confused. 29 states and few union territories. And if you want to get top performing stores or stores sorted in descending order by generated revenue within each state, okay, there is no need to globally sort. Whether you sort by state or not, it doesn't matter. But within each state, the data has to be grouped, and then data has to be sorted in ascending or descending order within each state. Okay, that is the example of by key sorting or by key ranking. If you want to do it globally, it's called as global sorting or global ranking. If you want to do by key, it is called as by key ranking or by key sorting. So out of the 100% use cases on sorting and ranking, 70 to 80% is if we can do sorting or ranking by key, it is enough. Only 20% probably might require the global sorting or ranking. Okay, so if you want to, so one of the advantage of Hadoop or big data ecosystem such as Spark, MapReduce, etc. is when it comes to by key sorting or by key ranking, it gives you higher degree of scalability compared to traditional RDBMSs like Oracle. In Oracle, sorting and ranking is typically single-threaded. Even if you give parallel hint, if you are familiar with Oracle, you can give parallel hint to run the query using parallel threads. If there is order by clause in the query, sorting will happen in single-threaded mode. Okay, and sorting will happen when you have group by clause and several other clauses. Even though you don't have order by as part of your query, still sorting happens. Okay, so wherever you require by key sorting or by key ranking using these Hadoop based technologies or MPP platforms, you can get much better degree of scalability. Okay, that is the difference between by key sorting, by key ranking versus global sorting, global ranking. Wherever it is inevitable to do global sorting, you have to do that. Otherwise, you should give top priority to by key sorting or by key ranking, which does mean that data is globally sorted on the entire data set. Within a particular key, data will be sorted, and that is enough in some cases. And in that case, you should consider by key sorting or by key ranking. Now, when it comes to Spark, okay, to perform global sorting, we use sort by key. Sort by key will sort the data globally. So here I will run this local on my local PC. I'm launching SBT console. So for this purpose, I will be using data set called products. Okay. Okay, so products path is, okay, first I need to import org.apache.spark. Okay, then val conf sc equal to new spark context, new spark conf set app name, sorting and ranking dot set master local. Okay, then val products equal to sc dot text file slash users slash ITversity research data retail underscore DB products. Okay, and in this there is one record filter spec dot contains 685 dot collect dot for each println. You see there is one record. Data is comma separated. Okay. Now if you see, this is product ID, this is product category ID, and this is product name, and product name have comma in it. Okay. Now if I use comma as delimiter, this will be the first field, this will be the second field, this will be the third field, this will be the fourth field, this will be the fifth field, and this will be the sixth field, which is product price. And I'll be using product price for sorting and ranking purposes. Except for this record, for all the other records, this price will be the fifth price, whereas for this one, this will be the sixth price. Sorry, sixth element. Okay, so for example, if I give val s equal to I'm just creating an okay, val a equal to, it is of type array, and a of 0 will give the element in the array. Now if I say a of 0 dot split by comma, you can see this is first element, this is second element, this is third element, this is fourth element. Yeah.
There's already one code.
Yeah, this is third element, and then this is the fourth element, this is fifth element, this is sixth element. For all the others, the fifth element is the price, which is not null. Only for this one, the fifth element will be null value. Hence, if we try to process the entire data set, it will throw some exceptions. As a workaround, I will be filtering this data out. Okay, so here I just have to say not. Okay, sorry. I will create a new RDD where I use not here and ignore that one record. Okay, now if you say products.count, you got 1345. Products filtered.count got 1344. Only with that one record we have discarded. Now let us say products filtered dot take off or collect for each println. You got the data, and in this case it is just sorted by the product ID. That is how the data is there in the file. Now I want to sort the data in descending order by price. So we can use price as key and apply the sort by key, because sort by key require data in key value pair. So Vicky was asking about how we are not specifying key explicitly, then how it is determining. So before applying join or reduce by key or aggregate by key or sort by key, we are using map function to define the key. Okay, so the previous step we are taking care of that key. That's where we don't need to explicitly say what is key. We are always creating a paired RDD, which as part of that pair, the first element will act as key. Okay, that's how key is identified. Okay, so now I am doing that. I'm saying product map equal to rec dot. If you want, here also you can use case class the way we have used earlier. Otherwise, you can use the regular string processing like this. Dot map rec implies. As part of the key, first I want to get a pass with comma as delimiter, and then get the fifth element, which is price. So 0, 1, 2, 3, 4. Okay, 4, and it is of type float. So we have to typecast to float. Otherwise, it will be sorted as string. If it is sorted as string, 32 will be treated as the higher value than 100. Based upon string based sorting, 3 will always be considered to be higher than any number which starts with 1. So casting is very, very important. You never forget to cast, not only with respect to sort, even with join or anywhere. If you want to use it as key, and if the key's original type is of numeric value, you have to cast it to its original type. And then value, I want to get the entire record. So in this case, I am using rec itself as value. Okay, and then hit enter. Now the product map is of type tuple. It is called as paired RDD. First element is of type float, which is key. Second element is of type string, which is the entire record. Now, if I say products map dot sort by key, and then collect, and then for each int ln, and hit enter, you see data is sorted in ascending order by price. If you want to change it to descending order, you just have to pass false, which is boolean, and hit enter. Now data is sorted in descending order. Okay, so in this case, the key is of typical type. There is only one element in the key. Now within this data set itself, let's say I want to sort it by first by product category ID and then by product price. Okay, it is typical scenario where you want to sort it by product category ID, so that you within the category you can see the prices, the records in ascending order or descending order by price. In that case, what you have to do is, as part of the map function, you have to create a composite key. Okay, so first I want to, so here I will be writing in multiple lines so that it is much better readable. Okay, so here I am saying val r equal to rec dot split comma, which will give us the array, and then this is how I want to build it. The first element is of type r of 1, which is product category ID, and then it is of type int, so we have to say to int, and then r of 4 to float, and then the record. Okay, record is of type string, so we don't need to worry too much about it. And then you can say sort by key, collect for each int ln, and hit enter. Now you see within each category we got the data in ascending order. So 59, 70, 100. So if you see, it's all ascending. If you want to get it in descending order, ascending by product category ID and descending by product price, you have to run like this. As part of the key, you can say, if you say false, everything will be in descending order as part of sort by key. But if you say like this, minus, and then sort by key, and once we sort by key, I don't want to print this. And also, I don't want to results to be in the form of tuple. I just want to print the record from here to here. So for that purpose, we can use the map function underscore dot underscore 2. If you say underscore dot underscore 1, it will give this one. Underscore dot underscore 2 will give this record. And then collect, and then for each println and hit enter. Now you see data is in the descending order. Earlier it got hundreds at the last, now it got 28 at the last, and if you go up, it is in the ascending order from bottom to top. Okay, so this is how you can do the global sorting either on the composite key or the individual key. You can play with those things. Minus will work only in numeric types. If it is string type, then it will become a little bit complicated. You have to figure it out. Okay, and on top of these things, now one of the functionality will be to get top 5 from this data by price. Okay, so what you can do, products filtered dot we can actually say history and then get the previous code which we are using, and then copy to Sublime or some other editor. Okay, in this case, what I want to do is after applying the sort by key, I just want to get top 10 records or top 100 records, whatever it is. Okay, so here I don't want to use, means overall I want to get the top 100 records sorted by price. So here I am removing the composite key. Okay, and then as part of sort by key I am passing false so that data can be written in descending order. Okay, and now if you want to get top 10 records, instead of using collect, as the data is already in descending order, you can say take off 10. Okay, and it will only give top 10 records. 1999 is the top price, and it has given the top 10 records. On top of that, instead of using sort by key and then take, you can also say sort by key of false and then take. You can also say top. Top of 10. The top is an action. So here I have to give dot. And we don't need to use collect. Top itself is an action which will convert into an array. So we can just use for each and we can actually print. And you can see we got the top 10 records without specifying sort by key and then take of 10. Top will always sort the data in descending order by the key, and then it will give the n number of values from it. Either you can use sort by key and then take, or you can use top directly if you just want to get the top records. And then there is another action which is called as take ordered. So in this case, what we are trying to do, first we are applying the map function, and then either using sort by key plus take, or we are using top. So instead of even doing this, you can actually use take order directly. Okay, and as part of the take order, if you look at the syntax of take order, it will take the first parameter to return as many values as you want, and the second parameter you have to provide the custom comparator. Okay, and this is how it will look like. If I want to get top 10 records, I can say top 10, and then let me get the example. It's a little bit complicated. I'm going to my GitHub code, not the gist. I'm going to my GitHub code to get the example of take order. And this is how it will look like. You have to pass ordering. Okay, so in this case, we can use this. Okay, we have to pass like this. Okay, and here it is of type float. To float. And here we can say minus because we want to get the data in descending order. Okay, so now let us try. So this is actually Scala way of sorting the data. We are using Scala based API as part of this program. If your collection is of type float, you can use ordering of float dot on, and you can give the functionality on which data needs to be sorted. In this case, even though the record is of type string, we are extracting the float value. We are sorting based on that. That's why we are saying ordering of float. Now you see it got the same results. So here we are also skipping map function directly. Okay, so this is how you can use top sort by key plus so map plus top or map plus sort by key plus take, or you can directly use take ordered and give the comparator logic. Okay, that being said, we'll stop here. I will not be able to cover group by key now because it will take at least 1 hour time. So we'll start next Saturday. If you have any questions, I will take those. Otherwise, we'll wrap up for today. And for the examples of take ordered, top, and all those things, you can actually go to the GitHub code and you can search for global sorting and ranking, and you can see all the examples here. Okay. Okay, that being said, as part of the next week session, I'll be covering group by key, which will be very, very important for by key ranking. So far we have seen only global sorting and global ranking. If we have to do by key sorting and by key ranking, we have to use group by key. And I will talk about that as part of the beginning of the next class. And then we will get into the other concepts. That being said, I hope you are enjoying the session. People who are on YouTube live, if you like this video, please click on the like button. It means a lot to me. If you want to share with your friends, just click on share and click share with your friends. If you need environment to practice, just go to labs.itvarsity.com and sign up for the lab, and you can start practicing by following these videos. And if you have any questions while practicing, you can actually start writing your questions on discuss.itvarsity.com. We'll try to support you whether you are a paid customer for us or not. That being said, thank you very much. See you next Saturday for the remaining portion of Scala and Spark workshop. Thank you. Bye.